Morning, dear students. We are going to start our next chapter, chapter 25, application of integrals. Okay, so we have studied integration, and you know how to integrate different type of functions and what is the relation between integration and differentiation, everything. Okay, I hope all of you understood that. So now you are going to apply that into some problems which are extended. Okay, so you have studied integration for functions. Now you are going to apply this, okay, your knowledge into some curves. Okay, you know what is a curve is, and for curves how will you apply integration? Okay, that is we are going to study. That is sketching of simple curves. What is curve? Or curve means, what does it means? To draw the graph of a function y is equal to f of x. That means y is a function of x, right? So that type of functions you have studied in integration. And how will you integrate a function of x, a function of y, etc. So by using the result of differential calculus, we have the following steps. Okay, so you know about y is equal to f of x. What does it means? Now how will you sketch that function? Okay, how will you draw that function? So for that, you have to familiar with some terms. That is symmetry. What does symmetry means? Symmetry about the y-axis means it is a graph or a curve which is symmetric. Okay, a graph or a curve is symmetric about the y-axis when the equation is unaltered when x is replaced by minus x. That means a graph is symmetric to y-axis. You know there is two axes, x and y-axis, and we have to say the graph or curve is set to symmetry about the y-axis. Yes, what is it means? It means the given equation is unaltered, okay, when x is replaced by minus x. For any values of x, the given equation is not changing. Okay, then we say it is symmetric about y-axis. And for example, or in particular, an equation that gives only even powers of x repeats such curve. So even powers, x square, x raised to 4, x raised to 6, 2x square, like that. So that equations does not alter, okay, the values by replacing it as minus x. So x square, if is minus x square, it is x. So that, like that equation. So even function, that's why even function is saying. Okay, so even powers is it is symmetric about y-axis. So look at that first figure. It is symmetric about the y-axis. So it is symmetric about the y-axis. So it is, yes, it is on the y-axis. The y-axis would be perpendicular to the curve. So the figure is like this, should be like this. Okay, so it is the x-axis is there, y-axis is there. So y is equal to x square is this graph. So if we take a point x or minus x, the y is not changing. Okay, so this is the curve. So it is symmetric about y-axis, which means it is perpendicular. Should be perpendicular. And symmetric about y-axis is this. And next is symmetric about x-axis. That means if the equation is unaltered when it is when y is replaced by minus y. Okay, that is x is equal to y square, that is given in this figure. Symmetric about the axis, that means x should be perpendicular. Okay, the graph is symmetric to x-axis. That curve should be open to x-axis. Open to x-axis. Okay, if it is symmetric to y-axis, it is open to y-axis. That is how you have to draw the curve. Okay, this is how to sketch a curve which is symmetry. Okay, about y-axis and about x-axis. So this is the first step you have to remember when you draw the function y is equal to x square, like that. Okay, next is symmetric about the origin. Okay, origin. The equation is unaltered. That means when x and y are replaced by minus x and minus y respectively, the graph of the equation y is equal to x cube is symmetrical about the x-axis. If we change x and y, okay, it is replaced by minus x and minus y, the equation is unaltered. Okay, so we can say it is about x origin. It is about symmetric about origin. The equations like y is equal to x cube is symmetric about origin. Root x plus root y is equal to 1. It is symmetric about origin. And another equation is given, y is equal to minus x. Y is equal to x. So odd functions are, yes, the odd powers are symmetric about the origin. Okay, y is equal to x cube, y is equal to x, y is equal to minus x. These functions are odd functions. So these are, yes, these are symmetric about the origin. And next is symmetric about the line y is equal to x, which means changing x and y, the equation remains the same and the graph will be symmetric about the line y is equal to x. So root of x plus root of y is equal to 1, which is symmetric to y is equal to x. That is also given in that figure. And y is equal to minus x is another symmetry, which is the x square plus y square plus 2x minus 2y plus 1 is equal to 0. That is equation is symmetric about y is equal to minus x. So there has been 5 cases, that is about an axis, about the origin and about 2 lines. Okay, this is the symmetry and the examples has been given for you. Okay, and next term is point of intersection with axis. That means if we have how will you find the point of intersection? Okay, this will, you have to put x equals 0 and y equals 0. It will give the point of intersection with x axis and y axis respectively. Okay, we have given the equation, you have to put x and y as 0, then you will get the answer. That is the point of intersection of x and y axis. Okay, and also we can find whether the curve passes through this origin or not. That means 0, 0 satisfies the equation. If in the given equation we substitute 0, 0, then if this equation satisfies, okay, the given equation should be satisfied, then we can say it is the curve is passing through the origin. And also turning points. Turning points are, you have studied it earlier also. The first derivative f dash x is equal to 0, and solving which we get the turning points. Okay, and also increasing and decreasing curve. If f dash x, the derivative is greater than 0, it is increasing, and the derivative is less than 0, it is decreasing. Okay, okay, so these are the terms should be know if you have to draw a simple curve. Sketch a simple curve. Okay, so curves are, curve, what is a curve and straight line. Okay, so here we have talking about curves. Okay, sketch a graph of each of the following. First one is y is equal to x square minus 2x. X square minus 2x. That is first, that is we have going to draw. For that, first is symmetry. If it is symmetry, no, it is symmetrical about any lines. It is not symmetry. Okay, and origin. Yes, it passes through the origin. And intersection, if we have given intersection with axis to find, Put y is equal to 0, you will get the x. So 0, 0 and 2, 0 is 1 point. And if you take the derivative greater than 0, it is decreasing. And for which value it is increasing and decreasing, that is find out. And next is the dy by dx equal to 0, then the tangent at 1 minus 1 is parallel to x-axis. So these all should be known. And then first second degree equation is greater than 0, so y is minimum, like that. Okay, so for drawing this sketch, you have to know, you have to prepare a table. This is very important. Okay, we have to know some points, then only we can join that point and draw the curve. Okay, so we have found out it is yes, it is a curve. So for that, the x and y values have to be found out. Okay, for that, draw the table. Okay, look at that. The seventh point is the important one. So find the points. So draw a table like this, x, y. So the equation is given in x and y. Okay, so we have taking two values x and y and putting the values as given. That means from minus infinity to infinity, we can take we can put any values. So here minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. Okay, these are the values we have taken for x. Then we get the corresponding y. Okay, we can take the x values as arbitrary and then we get the corresponding y values for x. Okay, that is there. So for that, and we have just draw that using these points. Okay, that is, if we take y is equal to x square minus 2x, that is the graph. So from that you know it is a parabola. Always remember, y is equal to f of x. That curve is a parabola. This curve is known as parabola. Okay, it is a upward parabola. If y is equal to f of x is given, it is an upward parabola, that is, it is symmetric to y. Okay, and x is equal to f of y is given, it is symmetric to x-axis and it is a parabola that is symmetric to x-axis. So y is equal to f of x and x is equal to f of y are the equation of a parabola. Okay, so you should remember which should be the curve is. So x is equal to y and y is equal to x, such curves are parabolas. Okay, so y is equal to x square minus 2x. Okay, so we have to draw that parabola and it is upward. It is an upward parabola. So first you have to draw the table, then draw the x and y axis. Okay, and then represent these points like minus 3, 15. Okay, minus 3, 15. It is so much difficult to draw because the y is 15. It will be a very long parabola. So take 1 minus 1. Okay, 1, 0, 0. First you take 0, 0. Okay, first you mark the point 0, 0. Then minus 1, 3, minus 1, 3. X is minus 1, 3 is there. So minus 1, 3. Then minus 2, 8. 2 points will be there. So you can join that 2 points by drawing a curve. Then and point 0, 0 is there. So you will get a curve. So that is needed. And then minus 1 on the right. 1 minus 1, 2, 0, 3, 3, 4, 8. Okay, that is represented, and join these points using a curve. No straight lines, draw as a curve. Okay, joining this point. So this is the graph of y is equal to x square minus 2x. Okay. Yes. So you can take the arbitrary values for x and you get the corresponding y, and please plot these points and join by freehand. With your hands you can join this, and this curve, this shape is called a parabola, and it is an upward parabola. Okay, upward parabola. Yes. So this is the sketch. This is how to draw a graph. Similarly, the second graph, which is the second graph, x raised to 4 minus 1. Okay, x raised to 4 minus 1. Similarly, you can draw that by plotting the points and joining that point using your freehand. Okay, and next is the geometrical interpretation of a definite integral. What is a definite integral? Yes, we have a particular integral limit there. So particular, that is definite. It is defined in that. The integral is defined. So to prove that the area bounded by the curve, that is very important. Area bounded by the curve, y is equal to fx, the x-axis and the coordinates. X equal to a, x equal to b is integral a to b y dx. So this is very important question. This is the most important point or most important section in this chapter. You don't have to prove that, but the area bounded by the curve, okay, this should be remembered. You have to solve the problems using this equation. Okay, area bounded by a curve, the x-axis and the coordinates. Okay, area bounded by the curve, a curve should be given for you, and x or y axis, okay, x-axis is given. Okay, if given x-axis and the coordinate also, x equal to a and y equal to b, then the area bounded by that curves is integral a to b y dx. The given equation dx. You have to integrate with the limit from a to b y dx. Okay, that is the area. You don't the proof is not important, but the equation is very important, and if you have to you know the proof, then also it is easy for you. For that, a curve is taken, y is equal to fx, and c, okay, it is drawn, and c a db, which is x is equal to a and y is equal to b coordinates, and take the necessary steps to find out that. Okay, you can just go through this, just read this. Okay, and taking the limit, you will get integral y dx, that is integral f of x dx, and it is definite. You have to put the limit integral a to b f of x dx, which is the area bounded by that curve. Okay, so integral a to b f of x dx is equal to the area bounded by the curve y is equal to fx. The curve is there, x-axis is there, and the coordinate y is equal to b and x equal to a. So this is the important equation. Okay, and this is the first equation. Second is area bounded by the curve x equal to f of y, the y-axis and the coordinate, that's to say y is equal to a and y is equal to b, is integral a to b x dy or integral a to b f of y dy. Okay, similarly, that similar process is there. If it is bounded by the y-axis, y is equal to fx and the coordinate x equal to a and b, then it is integral a to b x dx or y dy, f of x dx, y dx. And if it is on the curve x equal to f of y and y axis and y is equal to a and b, integral a to b x dy. Okay, yes, this is the important equation for finding the area bounded by the curve, axis and the coordinate. And how will you calculate the area under a curve? Okay, we calculate the area under a curve. The most important step is to make a rough sketch of the curve. So you have to identify the what is the curve is. And remember that area lying above the x-axis will have a positive value, whereas areas lying below the x-axis which be the negative, and in some cases the area required may lie both above and below, which is the particular cases, and it is that needs some particular cases also. So remember, when you have to calculate the area of a curve, you have to draw the sketch. You have to draw the or sketch the graph. Okay, and then identify the curve is below the x-axis or above the x-axis. According to that, the sign assigns. Okay, the positive or negative value will be assigned. Okay, the first question is, find the area between the curve y is equal to x into x minus 3 and the x-axis. So, y is equal to x into x minus 3 and the x-axis. So, first what you have to do is draw the sketch. For that, how will you draw the sketch? Yes, taking the value of x, arbitrary x are to be trained. First, draw the table x, y. Put some values on x for arbitrary x, and then you will get the corresponding y. Plot that points on that x-axis, xy axis, and draw as a curve with your free hand. Join that points with your free hand and make a curve. And then it is with the x-axis, find the area. So it is, you will get the points, and that is the curve. Okay, curve, and you will get the limit point from 0 to 3 because it is on the x-axis. You have to identify the point on x-axis and which is common to the x-axis and the curve. That is the coordinates of x, that is coordinate x and b. So integral 0 to 3, you will, if you draw the curve correctly, you will get the points. So x-axis is there, curve is there, the points x equal to 0 and x equal to b. So the area bounded by the curve is a is equal to integral 0 to 3 y dx. What is y? Integral 0 to 3 x into x minus 3 into dx. And what is that? It is x cube by 3. Yes, open the bracket, x square minus 3x. So it is x cube by 3 minus 3x square by 2 from the limit 0 to 3. That is 9 minus 27 by 2. That is minus 1 by minus 4 1 by 2. Minus 4 1 by 2. The area has negative sign, which means it is below the x-axis. Look at that figure. Yes, it is clearly below the x-axis. The curve is clearly below the x-axis. So the answer should be in negative sign. If your answer is positive, then understand that your answer is wrong. If it is below the x-axis, the answer should be in negative. Okay, and we take the numerical value because the values are not negative. Okay, so we have the sign. The sign reminds you that it is the below the axis, but you have to take the numerical value for area because area cannot be negative. Okay, so take the numerical value, and the sign denotes, if the negative sign denotes the curve is below the axis and positive denote it is above the axis. Okay, for that also take the sign. Okay, and then take the numerical values. Okay, so this is, and next curve is given. Find the area between the curve y is equal to x into 4 minus x and x-axis from x equals 0 and x equal to 5. So it is given. So you have to draw first you have to take the x and y axis and plot the points. Find the table x, y. You can first put 0, then what will be y? It is 0. Okay, and put 5 into 4 minus 1, which is 5 into 3, 15. It will give you, and then you have to plot 15 also. Okay, you have to plot 15 also. The point 5, 15 also you have to plot. Okay, this is okay, sorry, this is not this. that is should be given, and then plot the points. If the answer, the area is negative, then it is below, and if the area is positive, it is above the axis. Okay, yes, it is given in your textbook. If you have any problem, please go and check it. And next is the modulus function. How will you find the area bounded by the modulus function? The function is y is equal to modulus of x minus 5. Okay, you have to find the area bounded by this curve. Okay, the curve is modulus function. What is the graph of a modulus function? You have studied in your previous classes. Yes, it is on a V shape, right? Yes, this is straight line. It should be in straight line. So x minus 5 if x minus 5 greater than 0, and minus of x minus 5 less than 0. This is the modulus function, and you have to take the graph. You have to draw the graph by putting the x and corresponding y values will be get, and draw the graph. The graph is in this shape. Okay, graph is in this shape, and given that x equals 1 is the axis. X equal to 1 is the axis, and the greatest modulus of x minus 5 is the curve, and the point 0 to 1, that is the coordinates. So first you have to draw is common to, which is the common, that is you have to know. So you have to first draw y is equal to x minus 1, which is a straight line, and y is equal to 5 minus x, which is another straight line. That is the graph for the modulus function. And next is x equal to 1, which means it is parallel to y axis, and that is. So this is the curve. This is the curves. Sorry, this is the figure. It is not a curve. This is the figure. And then, therefore, how will you find the area? For that, shade the portion which is common to this lines. Okay, modulus function has straight lines, so there is no curve. Sorry, I have spelled it wrong. There is no curves, there is straight lines there. So you have to find the area bounded by that lines. For that, find the common region. Okay, so the common region is the x equals 1. So that is the line, and common region is this, which is below the x, that which is below the line f5 minus x, and which is right to y axis, and which is left to x equal to 1, and above the x axis. So that small region is the curve. Sorry, is the area. That is the area. That is the bounded. That are the bounded. That shaded region is the bounded portion. Okay, which is bounded by that lines. Okay, and then integral 0 to 1 y dx should be calculated. Modulus of x minus 1, 5 is y. So integral 0 to 1 mod x minus 5 dx. It has, yes, it has that is 5 minus x dx, which is 9 by 2 square units, which means it is above x-axis. That is, it is positive. So it is above x-axis, and the value is 9 by 2. This is the required area. Okay, this is how you have to do in a modulus function. If you have given modulus function, draw the modulus function first, and then the corresponding given lines also, and then find out the common region, common bounded region like this, and find out the area. Okay, next is trigonometric function. Y is equal to sine 2x, 0 less than or equal to x less than or equal to pi by 2. So the limit is already given, coordinates are given for you. You have to draw the figure. You know the sine function, sine 2x, you know the figure. You have to draw the figure. For that, put the values 0 to pi by 2. You can put any values between 0 to pi by 2. Okay, that is given. So the limit is given. So you have to draw if you have to draw the figure, put the values between 0 and pi by 2. because it is particularly given. It is not just minus infinity to infinity, it is 0 to pi by 2. So you have to put the values between this. So pi by 12, pi by 6, pi by 4, pi by 3, 5 pi by 12. Because these all values you have no, so put that. And the figure is drawn 0 to pi by 2. It is a curve like this. Okay, and you know it is above the x-axis, it is not negative. Sine function is not negative, so we have taken that region. It is clearly bounded. Okay, so the shaded region is the bounded region. That area of that shaded region is the required area. So integral 0 to pi by 2 sine 2x dx, which is, yes, what is the limit integration? Minus cos 2x by 2 to the limit 0 pi by 2, which is 1 by 2 plus 1 by 2, that is 1 unit. So the area of sine, the area bounded by that curve is 1. Okay? Yes. Next is polynomial functions. So first you have studied the curves, area bounded by how to find the curve, and modulus function, trigonometric function, and next is next is polynomial functions. So find the area bounded by the curve y is equal to x cube, which is a polynomial. The x-axis and the coordinate x equals minus 2 and y, x equals 1. So first put the values, okay, from x equals minus 2. So we can take the values, put the values between minus 2 and 1. Okay, minus 2 and 1. And here putting the values 0, 1, minus 1, 2, minus 2, all the values. And between that, minus 1.25, 1.5, 1.75 is also calculated to, just to, if you have the main points also, 0, minus 2, minus 1, 1, 0, 1, 2. You can plot that also, then you will get the curve. But you have to just join the other points also. Okay, then you can use 1.25, 1.5, 1.75 also, and the negative of that. Then you get the small points and you get the clear curve. That is why it is taken. Okay, and it is coordinate, that quadrant, it is symmetric to both the quadrants, because if we take x and y, it replaced by minus x and minus y, just symmetric to both the quadrants. Okay, and then what you have to do is you have to split the integral. That is it is the integral from minus 2 to 1 by dy. Okay, that is the integral, but you have to find the bounded region. Okay, for that, yes, this is the bounded region there. Look at that area is the shaded region, is the bounded region. So you have to take the limit of that region, only that region. Okay, so it is minus 2 to 1. Okay, minus 2 to 1, but we cannot do that because it is split. So it is minus 2 to 0, minus 2 to 0, and 0 to 1. Okay, we have split that and then find it. Integral minus 2 to 0 x cube dx plus integral 0 to 1 x cube dx. Okay, and then integrate it. Okay, then if you draw the curve, you will, okay, that is. Next is exponential and logarithmic functions. Find the area bounded by the curve y is equal to log x to the base e, y equals 0, x equals e. Okay, you have to first draw the curve. This is the shaded region. Okay, find the answer. It's clearly given. Okay, yes. Next is two curves. Area defined by two curves. You have find here, you have studied early that one curve, axis and coordinates. Next is area bounded by two curves. If you have given two curves, y is equal to f of x and y is equal to some g of x, what is the area? Yes, the area is integral a to b f of x minus g of x dx. That is the area. So the figure is given, two curves is given. Okay, then when they have point of intersection, that is the area, that is the shaded portion, and you have to find that area. A and B is the coordinates. Okay. This is the one. Area between two curves is integral a to b y, that is of f of x dx minus g of x dy, y of g of x dx. Okay, for that is working rule is the x coordinate, that is the point of intersection of x coordinates of the curve to the limit of integration, that is the limits of integration, and then the area under each curve separately to be calculated. Okay, that is integral a to b fx dx and integral b a to b g of x dx should be calculated separately, and then subtract. Find the difference between. Okay, this is the working rule. So let us do the problem. Find the area included between curve y is equal to 4ax and x square is equal to 4ay. So clearly it is a parabola. Okay, because y is equal to fx, y square, which is also parabola. Okay, so y is equal to fx and x equal to yx. So two parabola which is symmetric to the y-axis and symmetric to the x-axis is given. You have to find the area bounded. Okay, yes, for that first you have to draw the figure. Draw the figure and then find the if the two curves is drawing, we get the bounded, which should be the shaded region, that should be given. Okay, and then find the coordinates and integrate. You have to integrate both the function. First you have to integrate both the function, then find the difference. Okay, this is integrate both the region from 0 to 4a. Okay, then find the difference. That is the answer. Similarly for if you have given exponential and logarithmic function together, two curves, exponential and logarithmic function, what will you? Okay, this is the shaded region. That example is given. Y is equal to 2 raised to x and y is equal to 2x minus x square. First is the y is equal to 2x, which is an x curve, and y is equal to 2x minus x square is a logarithmic. Okay. Okay. Polynomial functions also. Y is equal to x and y is equal to x cube. Y is equal to x is a straight line passing through the origin, and y is equal to, and y is equal to x cube is another one, which is a, yes, passing through the center, I mean origin, and is also a polynomial. Okay. Okay, the area of the bounded region. The exercises. Okay, so the textbooks contains the workup problems also. I don't give you all the workup problems, so please take time and do the workup problems there and try to do these exercises also. Okay, please practice your and take time. It will take time, but you will understand it. If you do the problems by your own, you will understand how will you find the shaded portion. Okay, how will you get the shaded portion. Okay, so do that and try to do all the exercises. Thank you, students. Have a nice day.